Hey everybody, Tommy Clayton here, OpenSciEd middle school teacher and lesson writer. Excited to dig into lesson 9 from unit 8.3, the forces at a distance unit. This is a really cool lesson because this is where we really put it all together. This is the moment where we are able to explain how the speaker works. We're able to go back and revise our initial model. And we are really excited to extend our thinking and start to think about like some really cool devices that can do crazy things with permanent magnets and electromagnets. So it's a pretty exciting lesson, a lot of different parts to it. So let's get right into it. All right, let's remind ourselves how we got here. So in the last lesson, we figured out like the last thing we needed to know, which is like how the coil is able to flip its poles. We knew that there was this back and forth push and pull, but we just didn't know what was like causing it. And so we figured out by using LED light and lots of experiments that the voltage in the wire flips directions. And when that happens, it flips the magnetic field or the poles of that coil, which gives us the push and pull against that permanent magnet. So in this lesson, we really want to put it all together. We're wondering like, how does the magnet and the electromagnet work together to actually move the speaker? So let's take a look at this lesson at a glance. This is a putting the pieces together lesson. It is 3 days. It's going to take you about 25 minutes to get everything set up. There's really no hands-on investigation in this. It does require students to have a device. There's another simulation, if you recall from previous lessons, that we're going to take a look at. And there are no additional related setup videos. All right, so this 3-day lesson kind of breaks down in the following way. So we have this first big chunk on the first day, and that's going to take us up till just the last part where we introduce this navigation, this home learning. And that's where students are going to go off and try to find some additional things in their everyday lives that use electromagnetic forces to make something happen. When we come back on day 2, we're going to put together a consensus model in our scientist circle, and then we're going to share out some of the stuff that we figured out from going home and exploring. So in that first chunk, we realized we can explain how the coil and the magnet work together to make the speaker move. We do that in small groups. And ultimately, when we put together our larger model, this is the moment where we realize we need to add new ideas about the current, about the magnetic poles, about the magnetic fields, and we need to update our model from lesson 6. And then we figure out from going home and checking out some things that there's some other related phenomena that use magnets and electromagnets. Then on day 3, we pivot to this cool part where we read about really big things that use big magnets or electromagnets. And we jigsaw those, and then we go back to our DQB and add a whole bunch of new questions. And essentially what we figure out is that magnets and electromagnets can actually move like really, really big or heavy things like a car or a train. And that's pretty crazy. We have a lot of questions about that. So this is how it really breaks down. On day 1, we figure out in small groups we can put all our ideas together to explain our original phenomena. In day 2, that's when we revise our consensus model together as a class, and we're able to explain how those changes in the fields can cause the speaker to vibrate. And then in day 3, ultimately, that's where we start to pivot to think about like, what can we do on a really big scale with magnets and electromagnets? So let's take a look at a couple of key moments that we want to highlight here. The first is this part 2. So this is where we return to our cause and effect tracker that we sort of have been working on in the last couple of lessons. And we want to add our new thinking from what we figured out in lesson 7 and lesson 8. This is where we pivoted to think about how energy is involved in this. So we want to make sure we're capturing those cause and effect relationships. And then also, we're going to use a new version of the interactive. Again, there's a new link. It adds new features from the previous lessons to just confirm what we figured out or help us think about some other relationships that we haven't necessarily added to our chart. So after we do that, we get into small groups, and that's kind of the last thing we do on that first day, which is to get together and develop models in small groups. And then we bring those models together in the second day when we build a consensus model in our scientist circle. And so what we're doing is we're going to take the model from lesson 6, which is sort of that like top part of the model on your screen, and we're going to add that bottom piece. So we're going to add the new things that we figured out about energy and what happens when we bring the magnet and the coil closer together in terms of that energy, and what that field looks like. And then we're going to add this new big idea we figured out in the last lesson, which is the current in the wire has something to do with this, and that changing direction is ultimately what causes the magnetic field to flip. And it is the music player that's actually doing that. And that's about the level at which we're going to go. We don't need to go any further as far as what the music player itself is actually doing. Then we think about and share our things that we found from home, and then we're introduced to some readings about really big magnets. So we have 3 different readings. We're going to put students into groups and give them the opportunity to become kind of an expert on either junkyard magnets, maglev trains, or electric motors. And then we're going to jigsaw those. So we're going to go off and join a group of friends that have looked at the other devices. We're going to share the big things about those devices. And most importantly, we're trying to look for similarities and differences between the bullet train and the speaker, or the electric motor and the speaker, whatever it might be. So the lesson then wraps up with adding some new questions to our driving question board. And so this is where we're going to pivot and start to think about the factors that affect electromagnetic or magnetic forces. And so in the next lesson, we want to further investigate how distance may affect the strength of forces between the magnets. So we're going to get some really good data on that by doing a pretty controlled experiment. So a couple of tips and tricks for this lesson. In part 7, when we are reading about these different devices, we really want to motivate questions around factors. So you really want to try to walk around, listen to what kids are saying, really encourage them to document or write down what they're saying, because in the next part of the lesson, we're going to go to our driving question board and we're going to document these questions. So you don't want to lose sight of those great questions around factors, around what makes electromagnets strong or permanent magnets strong. Furthermore, in lesson 11, students wrap up this whole unit by developing a model for a device. It can be, fictitious or real, and they're going to include an electromagnet in it. And so we are really shifting toward thinking about the practicality of electromagnets, how they can be used to solve problems, and also how we can play around with different factors to make them strong enough to do things like move cars or move trains or pick up really heavy, big pieces of metal. There are a whole bunch of cool words we are going to encounter in our readings. That's magnetic levitation, ferromagnetic, and voltage in the extension. There is an extension for kids who are really enamored with electricity and want to find out more. So you're going to want to return to the word wall at some point after the students have read through all of the different articles and add these words and their definitions to the word wall. We have some materials from previous lessons, so we're going to go back to the driving question board and add new questions, revise some questions. At this point, also, you'll be able to take some off that you have answered. We are going to create a class consensus model that builds off of lesson 6. So you're going to add new findings to that. And then we have an addition to our cause and effect tracker in this lesson to bring in the new things that we figured out in lesson 7 and lesson 8. All right, and that's going to do it for us. Come back and join us for lesson 10. We're going to see how we pivot to start thinking about factors that affect magnetic fields and how we can relate these to our everyday life, and how we can explain more of these devices that we have seen a lot and are on our related phenomena. Have a great day, and we'll see you in the next video.